Hey guys, I'm back with a new video. In this video, we'll learn about decorators in Python. Well, I did touch over decorators a bit in the video on getters and setters, but in this video, we will see why we need one and what problems decorators helps us in solving. Now, the first question that must come in our mind is that what is a decorator? Now, a decorator is just like some magic. So it's just like some salt and spice in your meal to make it delicious. Add some functionality on top of the existing functionality of a function or a class, for example, and modifies its original behavior. So now we know that functions in Python are first-class citizens, which means that functions in Python are objects. They can be referenced to, passed to a variable, and returned from other functions as well. This also means that functions can be defined inside another functions, and they can also be passed as argument to other functions, which we will see when we will define one decorator. So let us define a simple decorator function to measure the execution time of certain functions. So this will be a good exercise as well. So decorator for measuring the rough execution time of certain functions. So let us import the required packages first, which I require in order to compute a rough estimate of the execution time of certain functions. So let us import the core module time. So from time, import the functionality, so time, and let us define a decorator that will be used to compute the execution time of a function that we will pass as an argument to this function. Just a while back I told you that we can define functions right inside our decorator functions as well. So right inside the decorator function, which I will define like this, so compute execution time, and this will receive a function. So let us name it as action function. Now right inside the decorator function, we have to define an inner function. So let us name this as wrapped function, and this wrapped function can receive some arguments and keyword arguments. So let us add them to the wrapped function. So asterisk args, double asterisk keyword args, like this. Now right before we execute our action function within this wrapped function, let us start the timer using the time method that we imported from the time core module. So to initiate the timer, I can say start time. So I will run the time function right on line 7. And then right below this, let us invoke the action function that we got as an argument to our decorator function. Then right here, let us invoke the action function that we got as an argument to our decorator function and pass to it the arguments and keyword arguments that we will eventually get from outside from the function which was invoked by the user and had a decorator on it, which I will define in just a minute. So whatever argument and keyword arguments are supplied by the user during the invocation, we will receive them right here as arguments of the wrapped function, which we can simply pass on to the action function like this. So asterisk args and keyword args. Now let's get the time right after the function execution is done. So I can say end time, and let us print the total time taken by execution. So f string, so I will use the f string that we learned in the previous video, and I can say total time taken by, then we need to define the curly braces to interpolate some variable. So here I want to interpolate the name of the function, which I can get by saying action function dot double underscore name double underscore. Okay, so this colon should come here, and then another placeholder where I will interpolate the difference between the start and the end time like this. And then right after this definition is done, and within the compute execution time function, let us return the wrapped function. Now let us make use of this decorator on any function on which we want to run our execution time analysis. So let us first add it on a factorial function that I will define in just a minute. And here what will happen is that the factorial function will get passed as the argument to the decorator function, which means that the action function will be our factorial function, and the number for which we want to compute the factorial will go to the asterisk args right here. So right inside the wrapped function, that we got from the invocation of the decorator function when we returned it. So first let us define the factorial function, def factorial, and this will expect a number. And to add some existing functionality of making the execution time analysis, I will have to add this decorator right on top of the factorial function by saying at and then compute execution time like this. So right inside the decorator function, let us define another function to actually compute the factorial of a number. So whatever number we are getting right inside this, I'll pass this to another function and I will name it as give factorial and pass the number like this. So right here I will define a recursive implementation of the factorial function. So def give factorial. Let me zoom this out so you can see the complete code. This will take on the number, and if the number is 0 or the number is 1, then you will return 1. Otherwise, if the number is anything other than 0 or 1, you will say return number into another invocation of the give factorial function, but here I will pass number minus 1 like this. So for computing 5 factorial, what will happen is, if we pass 5 right here, this check will not run. So we'll say 5 into give factorial of 4, which is 5 minus 1. Then give factorial of 4 will run, which will give 4 into give factorial of 3. Then for 3 we will have 3 into give factorial of 2. For 2 we will have 2 into give factorial of 1. And then what will happen is, this case will run, which says if the number is 1, you simply return 1. And so the end result will be 5 into 4 into 3 into 2 into 1, which will come out to be 120. So now we are done with the implementation of our function on which we want to perform this analysis. Let us invoke the function to see what we get. So right here I will say factorial 5. Let us zoom this up back again and let us run the file. So let me go to the correct folder. So cd and python decorators.py, and you can see we are getting the expected output that 5 factorial is 120 and the total time taken by the factorial function is 0.0009 something, which we are getting from right here. So you can see this works fine. So I believe this implementation is very good for understanding decorators in one go. Now let us test our decorator function on one more function. So let us define a function for summing up numbers in a list, numbers 1, 2, 3, 4, 5, and we want to get the sum 15. So for this I will make use of the reduce function that we had learned in one of the previous videos. So let us import the reduce functionality from the functools core module. So from functools import reduce, and then let us define our decorator on the sum function. So compute execution time, and this is sitting right on our function, which is the sum function, which expects to get a list of numbers. Now from this sum function we want to get a consolidated value, which is the sum of this list. So we are reducing a list of numbers to an integer. So that is why we are making use of the reduce function, though you can use any other way of computing the sum of the numbers, but let us go with reduce for now. So print reduce, and this takes on the function that you want to run on each item of your iterable. So lambda function, and this will take on the accumulator as the first argument and the number that we are currently on, and to the accumulator we can add on the current number. Let us pass our numbers iterable on which we want to run this lambda function, and the start value of accumulator, which is the third argument of the reduce function, which is 0. So let us invoke it right here and run the file to see the output. So sum, and pass on the list of numbers that we defined right here. So let us run the file to see what we get. So you can see the sum comes out to be 15, and the total time taken by our sum function is 0.2 something. And if I again run the file, you can see this time we are getting different time. So this time thing depends on the processor. It is just giving you a rough estimate of the execution time that is taking for these two operations to get performed. So this was all about the video on decorators in Python, where we covered what a decorator is, how to create a decorator, which we saw in this simple exercise of measuring the execution time of various functions, namely summing up numbers in a list and the factorial function. So if you liked the video, do give it a thumbs up, subscribe to the channel, hit the bell icon to get the notification for all my upcoming uploads, and I will see you guys in the very next one.